Hello everyone, welcome back to my YouTube channel. This is Sangeeta BJ from Sri Venkateshwara College of Engineering from the Department of Information Science and Engineering 4th semester. Today in this video we are going to discuss about the subject discrete mathematical structures and the topic is the binomial theorem. Binomial theorem, unveiling the patterns of expansion. The binomial theorem is a fundamental principle in algebra that reveals how expressions raised to powers can be expanded systematically. Understanding this theorem allows us to break down complex polynomial expansions into manageable terms, unlocking patterns that apply across mathematics, science, and engineering. What is the binomial theorem and why should you care? Definition. The binomial theorem explains how to expand powers of a binomial expression like a plus b whole power n into a sum involving terms with coefficients, powers, and variables. Importance. This theorem simplifies polynomial expansions and connects algebraic expressions to combinatorics and probability, making it key for advanced math and real world problem solving. Scope. From pure math to finance and computer science, understanding this theorem helps tackle equations, model outcomes, and optimize calculations efficiently. Pascal's triangle, a visual gateway to binomial coefficients. Structure. Pascal's triangle is a triangular array where each number is the sum of the two above it. It provides coefficients used in binomial expansions. Rows start with 1. Symmetrical patterns form. Each row corresponds to powers in the expansion. Connection to binomial theorem. The nth row of Pascal's triangle gives the coefficients for the expansion of a plus b whole power n, making it a powerful visualization tool. It simplifies finding coefficients without manual calculations of combinations. Factorials and combinations. The building blocks of the theorem. Factorials. A factorial, n factorial, means multiplying all positive integers up to n. It's crucial in counting permutations and combinations. Combinations. Combinations determine how many ways to select items without order, represented as NCR. It is calculated using factorials. Role in binomial theorem. The theorem's coefficients are derived from combinations representing the number of ways terms can be chosen for each power. A binomial theorem formula. A step-by-step breakdown. General expansion. A plus b whole power n is expanded into summation from k equals to 0 to n of nck into a power n minus k into b power k. Coefficients. Use combinations nck equals n factorial divided by k factorial into n minus k factorial for each term's coefficient. Term powers. Exponents of a decrease from n to 0 while b increases from 0 to n. This formula elegantly organizes the terms and coefficients, enabling quick and accurate polynomial expansions of binomials raised to powers. Example 1. Expanding x plus y whole power 4 with is. Identify terms. Here n equals 4, so 5 terms will appear according to the theorem. Calculate coefficients. Using Pascal's triangle or combinations 1, 4, 6, 4 and 1. Write expanded form. Result. X power 4 plus 4x cubed into y plus 6x square into y square plus 4x into y cube plus y power 4. This example illustrates how the theorem turns algebraic expressions into neat polynomial expansions with predictable terms and coefficients. Example 2. Finding a specific term in 2a minus b whole power 7. Step 1. Identify term number. Fifth term means k equals 4 in the expansion formula. Step 2. Calculate coefficients. Use combination like 7C4, which is equals to 35. Step 3. Compute variable powers. Expression 35 into 2a cube into minus b power 4 equals 35 into 8a cube into b power 4. Step 4. Final result. Result is 280 into a cube into b power 4, taking the positive value from even power of negative term. Common mistakes and how to avoid them. Incorrect coefficients, mixing up factorial calculations or Pascal's triangle rows leads to wrong terms. Sign errors. For negative terms, forgetting to apply powers to signs causes mistakes. Overlooking zero index. Term count starts at k equals 0. Skipping these leads to missing terms or incorrect positions. Power misassignment. Exponents must always sum to n, so track a and b carefully for each term. Accepting these pitfalls and using step-by-step methods helps ensure accuracy when applying the theorem. Real-world applications from probability to finance. Probability theory. The binomial theorem helps calculate probabilities in binomial distributions like success or failure in trials. Financial modeling. Used in option pricing models, it expands complex functions to estimate future values and risks. Algebraic simplifications. Engineers and scientists apply the theorem to simplify polynomials in physics and computation tasks. Summary and next steps. Mastering the binomial theorem. Key takeaways. The theorem allows systematic expansion of binomials using coefficients from combinations or Pascal's triangle. Practical understanding involves mastering factorials, combinations, and sign or power rules. Real world applications broaden its importance beyond pure math into finance, science, and engineering. Next steps. Practice expanding binomials with varying powers. Explore related concepts like multinomial expansions. Apply the theorem to real world problems in areas like statistics or finance. Thank you for watching. Please do like, share, and subscribe to my YouTube channel.